So what is a permutation? Well, basically what a permutation is, it's an ordering, okay, of a group of objects. And we'll take a look at some examples in a little bit, but first let's take a look at some formulas here. What we have is NPR, okay, which is basically out of n items, how many ways can you pick r items, okay, where the order is important. So the formula is n factorial over n minus r factorial. Whereas combinations, NCR, out of n total items, how many ways can you choose r items where the order is not important? And I'll show you an example in just a minute, but this formula is n factorial over n minus r factorial, r factorial. Okay, so take a simple example, like say you have a hat with 3 marbles, okay, in it, A, B, and C. And you just want to find out how many ways are there to pick 2 marbles out of the 3 at random, okay, here. How many ways are there to pick 2 where the order matters? So here what we're going to do is we're going to do permutations. This is 3p2, which is 3 factorial over 3 minus 2 factorial. 3 factorial is just 3 times 2 times 1. 3 minus 2 is 1 factorial, which is just 1. And you can see we have 3 times 2, which is 6. So if we want to write these down really quick, this is going to be AB, or you could get B and then A. That's considered a different permutation. That's a different outcome because order is important. You could get, let's see, AC, CA, and what else? You could do CB, and you could also do BC. So you can see there's 6 different ways to pick 2 marbles out of the 3. Now, if we were doing combinations, okay, let's do the exact same problem. How many ways are there to choose 2 out of the 3? Well, that's going to be 3 factorial over 3 minus 2 factorial, 2 factorial. Okay, so if we simplify this, we get 3, 2, 1. 3 minus 2 is 1 factorial, which is 1. 2 factorial is 2 times 1. And you can see the 2's, the 1's, okay, and we're left with 3 divided by 1, which is 3. So let's go back to the outcomes here. Notice A, B, and BA, from a combination perspective, those are the same 2 marbles. So whether you get A and B, B and A, you don't really care. You say, well, I've got the same 2 marbles, right? So that's just one outcome. Here we've got A and C, C and A. Those are the same 2 marbles. And C and B, B and C, those are the same 2 marbles. So you can see when you're doing combinations where the order doesn't matter, you're going to have fewer possibilities, fewer outcomes. And you can see here in the formula, this r factorial, okay, here in this case, 2 factorial, what you're doing, because there's 2 items, and you can have them 2 different ways, you're dividing out those duplicates, okay, or those multiplicities. So this is just a simple example. Let's get into some other examples. Let's do this one here. How many ways can you arrange 5 books on a shelf? Okay, where the order is important. So you want to put the books like that. Well, there's a couple different ways to do this problem. One way to do it is just to diagram it out like this. And you can say, well, there's 5 choices for the book that I put here, right? Then once I put that book there, there's only 4 books left from which to pick from to put in the second position. And then it goes down from there, 3, 2, 1. And if we multiply all those together, we get 120 different permutations, different orderings, right? The other way to do this problem is you could say, well, out of 5 books, how many ways can I pick 5? Okay, the P stands for permutations, but I just like to say pick 5. So out of 5 total, how many ways can you pick 5 where the order matters? So if we go to our formula here, the NPR formula, we have 5 factorial over 5 minus 5 factorial. That's 5 factorial over 0 factorial. And remember, 0 factorial actually equals 1. That's just something you'll have to memorize. 1 factorial is 1 and 0 factorial is 1. So this just ends up being 5 times 4 times 3 times 2 times 1, all divided by 1, which is the same thing we got here, 120. So you can see sometimes there's a couple different ways to approach these problems. Let's look at the next one. How many ways can you pick 2 co-captains on a team of 20? So visualize you're on a sports team. There's 20 players and you want to pick 2 co-captains. Now let me ask you a question. Does the order matter? Is there like a head co-captain and like a assistant co-captain, or are they the same? In this case, they're the same. It doesn't specify any importance as far as the order is concerned. So that tells us that we're going to be using which one? Permutations or combinations? Combinations, because the order doesn't matter. So what we're going to do is out of 20 players, we're going to choose 2. Okay, so this is a total. We're choosing 2. Let's use our formula, 20 factorial over 20 minus 2, which is 18 factorial, 2 factorial. If we expand this out, we get 20 times 19 times 18, dot, 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 all the way down to 1. That's what the factorial represents. 18 factorial is 18 times 17 times 16, all the way down to 1, right? And then 2 factorial is just 2 times 1. So you can see here that 18, 17, 16, all the way down to 1, those cancel out. 2 factorial is 2 times 1, but that goes into 20 10 times. So you can see there's 10 times 9, 190 different ways to pick 2 co-captains, and the order doesn't matter. Okay, last problem. I hope you're enjoying these videos. If you are, subscribe to the channel, and I've got more videos like these coming. You can check out some of my past videos as well. And let's take a look at the last example here though. In a 50-person race, how many ways can you award gold, silver, and bronze? Okay, so let me ask you a question. Is the order important? Yes, so the order is important, right? Because if you switch the finishers, somebody else is going to get the gold medal and somebody else is going to get the silver medal. So the order is important. So in this problem, we definitely want to use permutations, okay, NPR. And out of the 50 runners or 50 competitors, okay, out of 50, you're picking 3, gold, silver, and bronze, the first 3 places, right? So this is going to be